Now we're going to talk about putting things together. We have learned in a previous section that we could add or subtract anything we want to as long as we do it to both sides of an equation to maintain that balance. So if you'll remember, we've solved equations that look like this, and in order to get the x alone, we would have to do the opposite of minus 5. Well, the opposite of minus 5 would be to add 5. We can do that as long as we do it to both sides. So a minus 5 plus 5 is 0. So on the left-hand side of the equals, we would have x. And on the right-hand side, negative 4 and positive 5 would be a positive 1. So we learned how to solve those in a previous section. Then in the last section, we talked about solving things involving multiplication and division. We learned that there was a property that allows us to be able to multiply or divide anything you want to as long as you do it to both sides of the equation. So here we have x over 15 equals 2.3. And what we would need to do is to get rid of this 15 away from the x. Right now, x is being divided by 15. So the opposite of that would be to multiply by 15. Multiplying and dividing by the same thing is really just 1. So on the left-hand side of our equals sign, we're just left with x. And on the right-hand side, we would have 2.3 times 15, which would be 34.5. So our answer then would be x equals 34.5. Well, now that's great and fine if we just have one of those two situations happening. But what if we ended up with something a lot more complex like this? It's very important that you understand in what order to do things so that you can solve equations much more efficiently. And, there is a step-by-step plan. It's kind of like order of operations is working with numbers. You have to do things in a specific order in order to get the correct answer. Well, we need to have a step-by-step order so that we can solve these equations with no problems. So, here we have something that I took out of the textbook, and it says, step number 1, simplify each side separately. And then number 2, isolate the variable term on one side. This to me is just a little bit confusing. So what I like to do is I like to rewrite it using my own type of language. And so I like to write out my steps as this. First of all, you have to make sure you do all distribution, no matter what. Everything has to be distributed before you can do anything else. That's rule number 1. Now, once all distribution is done, then we're going to combine like terms on each side. So we're going to look at the left side and combine like terms, and look at the right side and combine like terms. When we're done with that, then we may still have like terms on opposite sides of the equal sign that we may need to combine. And then finally, we're going to get the variable alone. Now, let's look at a problem here, and let's see if we can follow those steps and see if it makes sense. Step number 1 says do all distribution. Well, in this problem, there is no distribution to do, so we're done with that. Step 2 says combine like terms on each side. So looking here at the left-hand side, we do not have like terms to combine. On the right-hand side, we do not have like terms either, so we're done with step 2. Step 3 says combine any remaining like terms. Well, we have an x here and an x here on either side of the equal sign. We do need to move those together because they are like terms. I prefer to move the smaller one if possible. So I'm going to remove 3x by subtracting it. I'm doing the opposite. And we can do that as long as we do it to both sides. So that's going to leave us 8 equals 5x minus 3x would be 2x plus 10. Now I still have like terms that I can combine. I can subtract 10 from both sides, and we're going to finish this up in the next video.